Hello, everybody. My name is Riley. I'm an engineer at Uniswap Labs, and today I'm going to talk about UniswapX. So specifically, I'm going to focus on how we use data to create UniswapX orders. Yeah, so by show of hands here, who knows what UniswapX is? Okay, cool. It's a decent amount of people. Who here has used UniswapX? Okay, nice, nice. All right, so UniswapX is a Dutch auction intents-based meta-aggregator that gives users better execution prices, MEV protection, and a gasless experience. So that's a lot of jargon. I don't think it's super meaningful, so now I'm going to go through and just briefly show you what it is. So to give you context, this is what our classic swap experience looked like before UniswapX. So the user came to our platform, they called one of our backend services, and we went and looked at all the on-chain liquidity that was either UniswapX v2 or Uniswap v2 pool or a v3 pool. Then we'd route your order to give you the most optimal price over those pools. And this was great. But with the growth in on-chain trading, there were new liquidity pools popping up that we weren't covering. So it's possible you could have got a better price by swapping through one of these other pools, and we're missing out on that. So that's why people built aggregators, right? And so the aggregators would look at all the on-chain liquidity pools and route your trade amongst them to get you the best price, right? So problem solved. Well, not quite. So there's always going to be more liquidity out there, right? So you have Coinbase has all this off-chain liquidity. There's always new market makers that have capital on hand that want to facilitate retail trading. And then you're always going to have the next new hot, on-chain DEX that aggregator might miss. So that's why we built UniswapX. So UniswapX, the meta aggregator, right? The user comes to our platform, they declare their intent to swap, USDC to DAI. They sign this message, they send it to us, and we broadcast it to a network of fillers. And then we kind of, put our hands up, and we don't have to do any of this complex routing. We let the marketplace solve it, and they compete to give the best price, right? So problem solved. Okay, not quite. So first, we had a parameterization problem. So this is what a classic swap looked like, right? You put in your input token, your output token, and then really the only thing you have to worry about as a user is your slippage tolerance. And it's only one number. We give you a pretty good estimate of this, and then we let you fiddle with it. So if you set this too small, your transaction is going to revert on chain, and you'll have to pay the gas costs. If you set it too high, you'll get front run, and you'll probably get wrecked. But still, it's only one number. It's not that much overhead to ask the user to put in the value here. But for UniswapX, we have 4 different fields now that we have to parameterize. So we have a DK start time, an end time, a start amount, an end amount, and then a total valid order duration. And we have all these fields because this is what the order looks like. So it's see, is this laser work? Not quite. So this is a Dutch auction-based order where in this example here, you're selling for ETH, and the start price would be $12.50. So then in the first 3 blocks that this order is live, the RFQ winner will have exclusive rights to fill it, and then as soon as that period ends, the order decays until the end price. And so the way it's structured is it creates like a market competitive pressure to fill this order as soon as it becomes profitable, and therefore returning some of that extra value back to the user. So in the classic swap, this is more or less what that graph would look like. If your trade was small enough, you're executing at the spot price, but as soon as you get too big, you'll get front run, and your execution is spot price minus your max slippage. So the drop off in that step function there is where we're aiming to return that value back to the user with UniswapX. All right, and so then when creating these orders, there's 3 things that we really care about. So one is the fill rate, the time to swap, and then the price improvement. And depending on how we parameterize the configuration of these orders, you're going to end up at a different point in this trilemma, this metric trilemma. And we think there's an optimal point where you're making all the proper trade-offs and still giving people good swap outcomes. Yeah, so for example, let's say we decrease the start time and increase the end time, so now this order is a lot longer. You have a much smoother decay curve. So now market makers they have a lot more opportunity to do all their calculations, look for different niche routes, find obscure price improvement in different places, and you're more likely going to get better price and have a higher fill rate. But then your time to swap is going to be hurt because you're just extending the length of the order. All right, maybe we take the decay curve and we shift it to the left. So now your start price is a little lower and your end price is also a little lower. Right, so all these orders are going to be super profitable for market makers. They're going to have a really high fill rate and they're going to execute really quickly. But your price improvement is probably not going to be that good. All right, now you shift it in the opposite direction, but you shift it a little too far. So now you're being really optimistic about the price that you're going to get for your order. So maybe you have a few fills that you do have that really good price, but probably a lot of these orders are just going to go expired because market makers aren't able to find that price improvement that you're looking for. Yeah, so when building these orders, we kind of had a good mental model of how we want to do it, but we had a chicken-egg problem here where we want to parameterize these properly and we want to look at data to do so, but without the data, we can't parameterize it. And we're not just going to make up some YOLO numbers and start, ship it to prod and start collecting that data. So we needed data to have good parameterization, but we need parameterization to have good data. So what we did instead was we bootstrapped our system. So we built these things called synthetic quotes, and essentially they're just parameterized using the V3 spot price. So in this example, this would be like an order that is 50 bips above the V3 spot price is your start amount, and then your ending price is 50 bips below. Okay, so that's half the system. That's like the quoting bit. We have this second portion that is the filling part. So this is where right now we have a bunch of market makers that are all competing and they want all these orders, but when we didn't have any volume, there's no incentive for them to be filling these orders. So we just built the most basic UniswapX filler bot, which pretty much just looks directly at the V3 pool liquidity and it'll fill your orders against then. So you're not going to get much better of a price in V3 because that's what you're using to execute, but it still achieves this like intention of completing the system end to end so we can start pushing orders through. All right, and then the last bit was simulating swappers. Right, so we weren't going to ship this out to real users, and I can only sit there and click the button so many times. So we built this thing called a frequent swapper bot, and essentially what it does is it just copy trades real on-chain swaps. So like in this example, you would load it up with ETH, and then it looks on-chain and sees like, okay, so what are people swapping with ETH right now? So they're swapping ETH to USDC. So it gets that synthetic quote I was talking about, then it posts it to this filler bot, it gets filled, and now we have USDC in the bot. So then now USDC, we're saying people are trading for Uni, it does the same thing, and now we have Uni. And then people are trading Uni for Bitcoin, blah, 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 and then we start back at the top. So this is a good way to get a bunch of volume moving through the system, testing on ourselves, without having to scale this two-sided marketplace from the get-go. All right, so how does this work now? So I'm going to talk just a little bit about how at this point, we have like pretty good beginning metrics and enough to start having users come through, but we want to continually monitor it, make tweaks to them, and in real time, see how it's affecting our swap performance. So there's two flows I'm going to go through. It's the price discovery flow, just the quote flow, and the order dissemination. So once we have a signed order, that's just broadcasting it out to our marketplace. Right? So you come to our website, you put in your trade, we fire off this quote request, it goes to one of our back-end services, and it sends off two simultaneous requests to our classic system, so we're getting that V3 spot price, and then our UniswapX routing system. So that goes to a bunch of market makers. So then we get all the quotes back, and we return the best quote to you, and at the same time, we're logging all those market maker quotes to our data warehouse, or at least the winning one we log. So now we have some of the data, but we still need more. Okay, so now you have your order parameterized, you submit it, it goes to our order service. As soon as we get that order, we also log some details about the order to our warehouse, and then we broadcast it out to the network. So it goes to the RFQ winner, who has that exclusive fill period, and then it also goes to the public marketplace for any fillers. And then everyone's competing to fill it on-chain. And as soon as that gets filled on-chain, we index the fill event and also stick that in our data warehouse. Okay, so at this point, we have quote data, order data, and fill data. But what we really care about is fill time, price improvement, and fill rate. So we aggregate all that into an orders table, and then we break it out into smaller tables from here. I think one of the interesting tables we build is this pricing table. So when a UniswapX order gets filled, to then retroactively look back and determine the price improvement, you have to have known the classic spot price at the time of fill. So this pricing table is constantly indexing fill events that we might think would be like a UniswapX pair. And we build this historical spot price table, essentially, so that we could look back and get that price improvement metric. So then we're able to build this metric dashboard from these data tables and kind of monitor in real time. We make a tweak to the decay amount. How is it affecting the time to swap or the price improvement or that fill rate? All right, so what's next for UniswapX? So we have a pretty good data system now. We think we filled it out. We're rolling it out to a lot of users, and we're moving some volume through it. But what are we planning to work on next? So the next thing we're focused on is UniswapX cross-chain. So I'm going to walk through the flow just briefly on cross-chain, and then I'll touch on the other things we have on the roadmap for UniswapX. Yeah, so in this trade, the swapper wants to trade ETH on, let's say, mainnet for OP tokens on Optimism. Right, so the first step is they lock up this input tokens in our order settler contract. And then the filler on the destination chain can see that, okay, this order has been initiated, it's been kicked off. Now I'm going to initiate the fill on the destination. So it sends in the OP token to the bridge fulfiller contract. And this fulfiller contract will notify the bridge and also send the OP tokens to the swapper. All right, then the third step. So we wait for a challenge. So this swap is like an optimistic cross-chain swap, where we're making the assumption that the filler is behaving properly and actually filling the user on the destination chain. But if they're not, we have this challenge period, so someone can go and challenge, send a challenge to this order settler contract and vie for the filler's collateral that they've locked up. In this example, they did send it, so then the filler can go and claim their tokens from the order settler contract. Yeah, so the next few things we're working on. So after cross-chain UniswapX, we're looking into building a gossip network for our orders. So in my previous slides, you could see essentially when the user posts this order, they're just sending it to our database, and we host it in AWS. And at any given moment, if AWS decides they don't like crypto anymore, they can shut us down, and then we have a bunch of downtime, and maybe we were able to migrate to a different cloud provider, but it's just not optimal. At the same time, too, Uniswap Labs could censor users. Right? We could say, we don't want you to be submitting swaps to us, and we could just turn you off. And so this is not decentralized, it's not censorship resistant, it's not a super reliable way to have this go for a long amount of time. And so our order gossip network would look something like this, where we imagine either maybe piggybacking off of an existing gossip network or building our own, but you have a bunch of order nodes, and then any client can connect to any one node and post their order. So then if one node is censoring you or goes down, there's still that reliability layer where you have a bunch of other nodes supporting the system. And then the last thing we're going to start looking at is a permissionless quoter system. So right now, if you want to be a quoter on UniswapX, you have to come to us and we onboard you because we don't have some decentralized reputation system. So if we just open it up to the public, you could have market makers come in and start maliciously quoting and doing things that hurt swappers, and we don't have a way of permissionlessly letting people in or kicking them out. So that's something that we're working on to build, and then hopefully we could open it up to the public for quoting. So right now, the filler network is open to the public, but the quoter network, we still have to onboard you. Yep, and that's it. Thank you. Cool. Oh yeah, any questions?
One question right here.
Thanks for the talk. How does the order settler resolve disputes?
That's a good question. So that's something we're still working on. We have a few different options. But essentially, the filler's locking up collateral, and then it's open to the public to go challenge it. So the idea is if you have enough time in between, you can assume that there's this profit incentive for the public market to go challenge this, and that challenger would also post collateral. So then if they're right, they collect the filler's collateral. If they're wrong, then the challenger's collateral gets taken. So that's roughly how it works, but I think there's a few mechanisms we're still figuring out exactly which one we want to go with.
All right, one more question, we're going to have to skip on.
Yeah, thank you for your report. The question is about your cross-chain plans. So will you use the graph data for computations, or it's not enough, and you will index it by yourself?
That's a good question. I think we're still like in the early phases. We're mainly focused on the protocol design right now, so we haven't quite got to all the indexing of data. So for currently, we do some of the indexing on our own, but like for single chain UniswapX. But I think we're definitely interested in maybe using the graph to index that as well. So yeah.
Awesome. Thanks, Riley.
Cool. Thank you guys.